Okay, so today I will show you how to make a fully functional dashboard using the Arduino. And while at least for now it's only showing the speed and RPM values, it's getting those values from the real car. And you might be asking, well, where is the real car? And the answer is this. This is the simulator of the real car that has the OBDII port, the onboard diagnostic port, which you can find in most modern cars. And I'm reading those values, the speed and RPM values, from that OBDII port with the Arduino board and showing those values on the Nextion display. And just to prove that everything works as expected, let's put it inside the real car, and here is a clip of me just revving my old diesel minivan, and the RPM gauge on the Nextion display is showing the very same values as the RPM gauge on the car's dashboard. So let me show you how to make this project from start to finish, and as always describing every single step, so you should be able to follow even if you have very little to no experience with Arduino and electronics. But before we start, let's talk about the sponsor of today's video, which is PCBWay, because if you are working on some electronic projects, sooner or later you might need PCB or PCB assembly or even things like 3D printing, and in all those cases PCBWay has you covered because they offer all of those services for a reasonable price. And if you need PCBs, if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. So thank you PCBWay, and let's get back to our project. As you have seen already, I'm using this device, which is the OBDII simulator, and this should basically act as a real car, except I don't need to sit in a real car as I'm recording this video, so it's mainly for my own comfort. It has the OBDII port, which is the onboard diagnostic port that you should be able to find in any newer car. Usually it's located below the steering wheel, but if you are not sure where to find it, just use Google. It's called OBDII because there was something like the OBDII before that, and it's a simple way how to get all kinds of diagnostic messages from your car. However, in addition to getting all kinds of warning and error messages, you can also get the real-time data, and that's something that we are interested in today. And as I turn this device on, this simulator has a few potentiometers which you can use to set some values, for example the coolant temperature or the fuel level, and of course the two values that we want to get today, and that's the vehicle speed and the RPM value. Now we want to read those values from the OBDII port, but that's not possible with just the Arduino. Which means that we need something between the Arduino and the OBDII port, and that's this board. This is the OBDII UART. The UART means serial communication, so it will convert those OBDII messages into serial messages, and that's something that the Arduino understands. This board is from Sparkfun, and the most interesting thing about this board is that it uses the ELM327 chip. And that's great, because you can find a lot of ELM327 boards on AliExpress for just a few dollars, so my hope is that once I make this project work with this Sparkfun board, I can then switch to those cheap boards from AliExpress. But again, for today, I will go with this board because it should work, it has a nice documentation, it's just a little bit bigger and a little bit more expensive compared to those other ELM327 devices. So I will use this OBDII cable. By the way, this small connector is called DB9, so it's the OBD cable to DB9 connector cable, and connect the simulator to the Sparkfun OBDII UART board. The OBDII interface also provides 12 volts, and this is used to power up the Sparkfun board, so you don't need any extra power supply. You can see that the power LED on the board is shining, which is a good sign. Now I can read those serial messages with Arduino, but I will not do that just yet. I will start with connecting everything to my PC first and try to get some data that way. And for that I need to convert the UART, the serial communication, to the USB, so I need the USB to UART converter. And I have dozens of different boards, from small ones to the big ones. There is no big difference between them. The main thing, the important thing, is that the Sparkfun UART is working on the 5V logic, so our board should also work on the 5V, and sometimes those boards will have a switch to change between the 3.3V logic and 5V logic, so just make sure to set it to 5V. As for the connection, as with all the serial connections, there are two data lines, the TX for transfer and RX for receive, and you connect it in a way that the TX should go to RX and the RX should go to TX. So the transfer from one module is connected to the receive on the other module and vice versa. Also, because the Sparkfun board is powered from the OBDII port and the USB to UART board is powered from the USB, so we have two independent power sources, it might be a good idea to also connect the common ground, so ground should go to ground. Finally, I will connect the USB to UART port to my PC, and let's open some terminal application. I will be using realtime, which is my favorite application, but I understand that with so many different options, the UI might be a little bit intimidating. Anyway, I will jump to the port tab, and I want to set the speed to be 9600 baud. And the port will be most likely the highest one, in my case that's port number 18. As for the settings, the parity should be none, the data bits should be 8 bits, and the stub bits should be 1 bit, which is kind of default settings for most of the serial communications. But it's also described in the documentation for this Sparkfun board, so if I scroll down, there is some information about connecting this board to the car using this very same cable, and here they have it connected to the real car, and here are the settings. So let me actually put it side by side. And then I will open the connection by unclicking and clicking the open button again. And the window stays empty because we are not getting any data until we ask for it. So if I scroll down in the documentation, it says that we should be using AT commands. I believe the AT stands for attention. And so the commands will always start with the AT. So let's type in AT. And one of the very first commands that we can use is ATZ, and it will restart the board. So let's type in ATZ and press the enter key. And that will restart the board and show us the version of the ELM chip, which is 1.3a. Actually, let me try to make this font slightly bigger if possible, so you can maybe see it better like so. And you can actually see that we don't see the ELM327, we only see the LM327, so we are missing the first character. But let's not worry about it for now and continue with the next command, which is the ATRV, and that should give us the current voltage. Now one thing to note is we are not yet communicating with the OBDII port. We are still only talking with the ELM chip, so we are getting the voltage that the ELM chip is reporting, not getting any information from the actual OBDII port. So let's try to type in the ATRV, and by the way, it doesn't matter if this is lowercase or uppercase, and press the enter key. And again, we see some kind of information, and we expect the voltage to be around 12 volts, but we only see 2.2 volts, and I think that the problem is that we are not getting the first character. Actually, I think what's happening is we are getting the entire message, so maybe we are getting 12.2 volts, but then we get the CR, the carriage return character, and then we are expecting to get a new line, so the line feed the LF character, but instead we get another CR, so it will jump to the beginning of the line and it will override the first character. So in the documentation, let's open the list of commands, which is this PDF file, and see if there is anything that could be helpful. And I think that the commands L0 and L1 are the ones that we are looking for, because we want to enable line feeds. So let's type in ATL1, so ATL1, and press the enter key. And now as you can see, we are getting CR together with the LF characters, so carriage return and the line feed characters, so it's rightly recognized as the new line. So let's try to run our commands one more time, so ATZ to restart the board, and that will actually reset everything, including our line feed, so ATL1 to get the line feed, and then ATRV to get the current voltage, and we are getting the 12.2 volts, which is the expected value. By the way, there is a settings inside the realtime that should handle the new lines. If I go to the display tab, there is this checkbox, which is the new line mode. And as you can read in the tooltip, it should handle all the line feeds as a new lines. But I think that the problem why this is not working is the second part of the tooltip, which says it will handle the CR as a new line once the next character arrives. And in our case, we were not receiving any character after the CR character, but we got it sorted out with this AT command. So let's move on and talk about the OBDII protocols. Because as usual, nothing is simple, and the OBDII can work on a few different protocols. And actually, if I take a closer look at our simulator, I can switch between different OBDII protocols in here. And that's nice because I can simulate different cars that way. However, how do you know which protocol your car is using? And thankfully, you don't need to know that. Because the ELM chip can detect the used protocol by using this AT command, this ATSP0 command. That said, this documentation is slightly wrong because it's saying that the board will reply with OK once the proper protocol has been detected. That's actually not the case, but let me type in ATSP0 and it will reply with OK. Again, it's just saying that I want to auto-detect the protocol once I receive any information from the OBDII port, but since I haven't received any information from the OBDII port yet, I don't actually know what is the protocol being used, at least not yet. And if I open the PDF with the AT commands, there is this command, the DP, for describing the protocol, for printing out the protocol name. So let me type in ATDP, and if I press the enter key, it's being set to auto, but we don't really know what is the protocol. And so to establish the protocol, to get the protocol name, we need to first get some data from the OBDII port, and that's where we go to the OBDII commands. As you can read in the documentation, we have to first specify the OBD mode, and there are 10 different modes, at least there are actually more than that. What we are interested in the most is the mode number 01, which is for getting the current data, for getting the live data. And then the next part is the parameter ID, which is a PID. There is a link to the Wikipedia page with many PIDs, but for now, we are just interested in establishing the protocol name, so we can use whatever we want, for example, the most important PID 00. And it's most important because it should be supported on all vehicles. So what we will do is we will send 01 for getting the current data, and then the PID of being 00 for getting, I guess it's getting us the supported PIDs, but we don't really care about what this comment is getting to us, because at this point we want to establish the connection and we don't really care of the supported PIDs, at least not for now. So in the terminal window, I will type in 0100, and what I haven't told you that you can include as many spaces as you want, those will be ignored. And if I press the enter key, watch what happens. It will say searching, because now it's searching for the actual OBDII protocol, and once it finds the protocol, it will reply with some data. And it starts with 41, and that's because it adds 40 hex 40 to whatever mode we were asking for. So we were asking for mode 01, so it's 41, and then it repeats the PID, which in our case was 00. And then we are getting the actual data, but again, in this case, we don't care about the data. We care about the OBDII protocol name, so if I use the very same command being ATDP to print the name of the protocol, it will now give us the actual protocol name. And sure enough, this is matching the protocol that I have set on the OBDII emulator. So let's finally get the speed and the RPM values. Let me turn this potentiometer to set the RPM to about 5000 RPM. And the other potentiometer to set the speed to about 100 km per hour or so. And then if I look at the documentation, we do have a comment for reading the engine RPM, which is 010C. So let me type in 010C, and we get the same reply of 41 because we were asking for the real-time data, and then 0C, which is the PID for the RPM, and then we get 2 bytes being 4E and 4B. And if I enter those values into the calculator, so 4E and 4B, that's the decimal number of 20,000, but that's not the RPM, that's the RPM multiplied by 4, so we have to divide it by 4, and we get our RPM value, which is around 5000 RPM, so it's matching the value that we have set on the emulator. So let's continue also with the speed. And if I search for speed in here, I believe there is a sketch, and I should be able to find the correct PID, which is this one. So it's 010D. So let's try it. 010D. And this time we only get 1 byte response. And again, if I use the calculator and enter 64 for hex, that's exactly 100 in decimal, which is matching our set speed, which is 100 km per hour. So this time we don't have to do any conversion. So we know how to get the RPM value and we know how to get the speed value, but before using Arduino, we need to talk about a few things. First of all those characters are yellow in this window, and the yellow means that those are received characters. So even when I'm typing something, if I type in 0, this is not what I'm typing, this is actually being received from the ELM chip. And that's because by default, anything that I send will be automatically echoed back into the terminal window. And I can easily see it if I click this half duplex checkbox in the real-time application. If I now type in 0, this red one is the one that I was sending, and this yellow one is the one that I received. So if I type in 1, again it will be sending and receiving, 0 sending receiving, and C sending receiving. And I'm not quite sure that I need that, so I can probably turn off the echo. And again, in the comments, there is this E0 and E1, and I want to turn the echo off, so it will be E0, so it will be ATE0, and it's saying OK. So if I now type in 010C, you can see that we are not receiving any characters until we press the enter key, and then we will get the response. And I think that this change will make the Arduino code much cleaner later on. I've already mentioned that the ELM chip doesn't care if you send the comments in the uppercase or lowercase, and that the spaces are ignored, so I can type in 0 space space 1 space 0 space space D, and it will still be treated as a 010D. But the opposite is true as well. We don't really need those spaces in the received message. And we can actually turn off the spaces by using a special command, which is, let me see this one, so printing of spaces, again 0 on 1 for off and on. So I will use the ATS0 to turn off the spaces, so ATS0 to turn off the spaces. And if I now type in 010C, I will get the response with the RPM, but again without spaces, which makes it a little bit harder to read, but it will make it easier to work with inside our Arduino code. Also, it will make it slightly faster because the ELM chip doesn't have to transfer that many characters. So let's quickly repeat what we have learned so far and what comments we want to send from the Arduino. We want to start with the ATZ to restart everything. That will also print out the version name, then the ATE0 to turn off the echo, then the ATL1 to add the line feeds, although this might not be needed for the Arduino code, then the ATS0 to remove spaces in the received messages, then the ATSP0 to automatically detect the protocol. Then we want to send any comment, for example 0100, that's only to establish the protocol name, so it will search for the protocol and give us some values, but we don't care about those values. We care about the protocol name, which we can get with ATDP, so this will give us the protocol name. And then we will repeat 010C to get the RPM value and 010D to get the speed. And that's pretty much all that we need to do inside the Arduino code. Now if I open the documentation again, there is some Arduino code down here, but it also says that this is the obsolete code, because Arduino has changed how the flash function works, but I don't think that's the biggest problem. If I look at the code, they are doing something that I would like to do as well, so they are sending the ATZ for restarting the ELM chip. But then the code waits for 2 seconds, and I don't like this solution very much because if the response only takes 1 second, it means that we are wasting this additional 1 second, and if it takes more than 2 seconds, well, then we have a problem. So I think that instead of waiting, we want to do something else, and if I take a look at the real-time application, you might have noticed this bigger than symbol. And this symbol actually tells us that the ELM chip is ready for the next comment, so instead of waiting, we'll just look into the received characters and we will not send a new comment until we will see this bigger than character. So that's the plan, let's get some Arduino board. And usually I would go with the Arduino Uno board because that's my favorite board for starting up the project, but I want to start simple and not use any display at this point. So whatever I receive from the Sparkfun OBDII port, I want to send back into my PC using the serial port. And unfortunately, the Arduino Uno only has one serial port, and that's those 2 pins, the pins 0 and 1. So if I want to connect both the Sparkfun board, which is using the serial communication, and my PC, which is also using the serial communication, that would be a problem. And there are different Arduino boards with the different number of serial ports. For example, I believe that the Arduino Mega has 4 of them. But today I will go with the Arduino Leonardo. And this table might be a little bit confusing because it looks like that we still only have one serial port, but that's not the case, because the Arduino Leonardo acts as the USB device like your keyboard or your mouse. So for the default serial pin, the serial 0 pin, we can use the USB communication. And then we can use the pins 0 and 1 for the serial 1 port. And that's the port where the Sparkfun board will be connected. So let me actually do that. Let's connect the pin number 0, which is the RX, to the TX pin on the Sparkfun board, and the pin number 1, which is the TX, to the RX pin on the Sparkfun board. And then same as the last time, let's connect the common ground, so ground from the Arduino to the ground on the Sparkfun board. Finally, I will connect the Arduino Leonardo to my PC using the USB cable and then open the Arduino IDE. And I will put the Arduino IDE next to the Arduino documentation because I want to use bits and pieces from the documentation, starting with calling the begin function. So let's open the documentation for the begin function. And there should be some example sketch, example code down here. And I want to use the serial number 0, so just the serial and the serial 1. So inside our setup function, I will just paste the serial 1 and serial 0. And the serial 0 is for the USB communication, and the serial 1 is for the Sparkfun OBDII board. And for that one, I want to also use the 9600 bauds. Actually, the speed for the PC is not that important because, again, this is being emulated by the USB, but let's keep it the same. And then I want to print some messages, and whatever I print to the PC, it doesn't quite matter, but I will just print what I'm doing. So I'm sending the ATZ command for restarting the board. And then for the actual Sparkfun board, I will send the ATZ command. And maybe before sending those messages, I want to wait a while, for example, I don't know, like 5 seconds. So I have the time to open the serial monitor. And then inside the loop, I want to print whatever I'm getting from the Sparkfun board back into my PC. And for that, I will open the documentation for the available function. So there again should be some code down here. So there is this incoming byte. So I'll copy this incoming byte variable. And then I will say if there is something available, I will print it out. But I have to make sure that I'm using the correct port because I want to read it from the Sparkfun board, which is the serial 1. So if the serial 1 is available, if there is something on the serial 1, I want to read it. So serial 1.read. And then I want to print it back into the PC. And for that, I will use the serial 0, and I want to print this incoming byte variable. And I want to probably treat it as a character, so just cast it to character variable. And I think that's pretty much all that I need at this point. So let's select the correct board. So go to Tools, Board, Arduino IVR boards, and select the Arduino Leonardo. Then the correct port, in my case that's the COM number 9, and then hit the upload button. And once this is uploaded, let's just ignore those problems. Let's open the serial monitor, and you can see that we are sending the ATZ into the PC. We are getting the ATZ from the ELM board because it's just repeating whatever we are sending. We are still getting the echo, and then we are getting the ELM327 with the current version. So we know that the connection between the Arduino Leonardo board and the ELM board works, and we are able to restart the ELM board. So what we want to do next is to look for this bigger than symbol, this bigger than character, and once we receive this character from the ELM board, we can start sending next command. So let's just move all the code for reading the byte into the setup function, like so, and of course we need to define the variable before the setup function. And I will place this if statement into new while loop, and I will say, for example, that while some new variable, for example, jump to next section equals 0, and the jump to next section I will define as a new variable and set it to 0 in the beginning. So while the jump to next section equals 0, I will look for the incoming byte and read it and keep reading it forever until, of course, I will receive the bigger than symbol. So I'll just say that if the incoming byte equals the bigger than character, in that case, I will set the jump to next section to equal 1, so I will jump to the next section. And the next section will be again sending some command to the ELM board, and this time it will be turning off the echo, which is the ATE0 command. So let me just update those commands. And then again, after sending this command, we will use the very same piece of code in here. Before uploading this to the Arduino, I need to make one small change, and that is to actually set the jump to next section to 0 before actually running this while loop. And just to make sure, I will also do it in here. And then I will click the upload button to upload it to the Arduino. And I will clear the content before receiving anything. And you can see that we are sending the restart the board and getting the information of the ELM version. And then we did send the ATE0 to turn off the echo and received the OK feedback. And just because we want to send much more comments this way, I think it would make sense to just turn this into a new function. So let's create a new function that will not return everything. So void for not returning anything. And let's call it wait for greater than sign. And we don't need any parameters. And what I will just do, I will just copy everything from this piece of code into our new function. And then just simply call this function. So after sending the comment, I will call this function and do the same thing after sending the ATE0 comment. And let's also send all the other comments which we want to run during the setup function. So that will be the comment ATL1. That's for adding the line feed. The next one will be ATS0 to remove the spaces in the incoming message. The next one will be ATSP0 to automatically detect the current protocol. Then we will send some comment, for example 0100 to establish the current protocol being used. And finally we will print the protocol name using the ATDP command. So let's upload it to the Arduino one more time and see what happens. And again, I have this 5-second delay, so I can click the clear button. And let's just make it bigger to see what we have received. And it looks like that we were able to send the turn of the echo, add the line feed, remove spaces, automatically detect the protocol. And then as we did send the OBD message, it was searching for the protocol, which we were then able to print using the ATDP command. So this is our current protocol. And at this point, the board should be properly set up and ready to give us the RPM and the speed values. And we want to get those values all the time, so I will put it inside the main loop. And for the RPM, I want to send the 010C command. So the 010C is for getting the RPM. And then for the speed, we will send the 010D. Now, instead of using this wait for greater sign function, I guess I will just copy the content of this function because I might be doing some changes. So just paste the code after getting the RPM and after getting the speed. And I will probably insert some small delay, maybe like 200 milliseconds after both the RPM and the speed. And that should be enough for the start. By the way, I'm including the delay because there is some limit of how fast you can get the information from the OBDII port. I believe I read it's something about 100 milliseconds, but it might be also depending on the car model, so just to stay on the safe side, I will start with having 200 milliseconds between sending the commands. So let's open the serial monitor and then click the upload button. And it should go over the setup, and after that, let me just enable the auto-scrolling feature. We should be getting the RPM and the speed values. And I still have the simulator set to about 5000 RPM and 100 kilometers per hour, so let's just double check this. The RPM is 4E42, so inside the calculator, 4E42, that's about 20,000, and again divided by 4, about 5000 RPM. And the speed is about 65 or 64, and the hex 64 is 100 or 65 is 101. It's oscillating a little bit, but it's reporting the same values as set on the simulator. Now, of course, we want to convert those hex values into the integer values inside the Arduino code, but the first thing to do will be to actually store those strings, because we are printing those strings to the serial port, that's this part, but we are not storing this data as a new string. So let's create a new variable, and that will be the C-style string, so the array of characters, and let's name it received RPM string with, for example, up to 10 different characters. And then I want to have a new integer value and call it received RPM string position, and that will tell me which character I want to replace with the incoming character. And I will do the same thing for the speed value, so received speed string and received speed string position. In the beginning, I will set the received RPM string position to be 0, because I want to replace it from the beginning. And then when I get the byte, let me actually make this smaller so I can see everything at the same time. I want to set the received RPM string on the position of the received RPM string position to equal the received characters, which is the incoming byte. And then I want to increase the received RPM string position by 1, so the next time I receive the character, I will be replacing the next character in the string. Now, to make sure that I properly set the length of the string, the last character should be the null character, the 0, which means that once I receive the bigger than symbol, that's the end of the string, and I will set the last character to be the null character. And just to make sure that everything works as expected, I will print it into the PC, so I'll just say received RPM string and print the content of the received RPM string. And maybe one more empty line. So again, as I'm receiving the characters from the ELM board, I'm feeding them one by one into our received RPM string variable. So let's upload this to the Arduino. And there should be a line saying received RPM string, and the content should be matching the content on the top. So whatever we are printing into the serial port using this serial print function, which is this one, should be matching the entire RPM string, which seems to be the case. So what we need to do is to look for the first 4 characters inside this received string, and if it equals 410C, it means that we have the value for the RPM, so we will store those next 4 characters, the 4E55 or whatever value we are getting, into a new string. So let me actually create one more string variable, and again it will be the array of characters, and let's call it RPM string. And I guess in this case we only need 5 characters, 4 for the actual value and the last one for setting the length of the string. And let's do the same thing for the speed string, although we are not storing speed at this point yet. And then after we print this received string, I want to take a closer look at the first 4 characters. So if the received RPM string, the first character, which is the character with the index of 0, equals character 4, And at the same time, let me just put this inside brackets. If the second character with the index of 1 is 1, then the third character if it equals 0, and the fourth character with the index of 3 equals C. In that case, we are getting the value for the RPM, and we will first store the RPM value string in our new string, which is called the RPM string. And I will simply say that the first character in the RPM string is the fifth character, so index of 4 from the received string. And I want to store 4 different characters going from 0 all the way to 3. And I'm getting the values from 4, 5, 6, and 7. And just to make sure, I will set the last character, the index of 4, to be null to set the end of the string. And now we want to convert this RPM string into the actual number value. And for that, I will use the function str to ul, so convert the string to the unsigned long integer. And the advantage of this function is it has the base parameter, so we can specify if our string is in the decimal or hexadecimal format, which is our case. We have this in hexadecimal. So back inside our code, I will create 2 more variables of the unsigned long type. And let's call this RPM value and of course the speed value. Then after we store the string, I want to set the value to the function, so str to ul. And the first parameter is our string, which is the RPM string. The next one, I guess we can ignore this one, so just set it to null. And the base is 16. And as mentioned multiple times, the RPM value is stored as multiplied by 4. So just set it to divided by 4. And finally, let's just print the value. So let's just print the RPM value like so. And we are printing quite a lot of stuff, but that's only for debugging. So let's just upload this to the Arduino. And if I stop the scrolling, we have the received RPM string, which is this one. And then we have the calculated RPM value, which is still around 5000 RPM, which is the value that I have set on the simulator. So this works as expected. So let me do the very same changes for reading and getting the speed value. The main difference compared to getting the RPM value is that we are now looking for the 410D characters in the received speed string. And then we want to only store 2 values, so 2 bytes in the speed string, first and the second in the speed string. And that should be the 5th character and the 6th character with the indexes of 4 and 5. And then we will again use the very same function, being the str to ul, to convert the speed string into the speed value, but we don't have to divide it by anything. And then I will print the speed value. And let me go over the code quickly and make sure that we are only printing the speed value and the RPM value and not flooding the output with so many messages. And once this change is done, let's upload it again to the Arduino. And even when I have some extra new line in the output, we are getting the calculated RPM and the speed values. So let me just remove the new line, which is this one, and upload it one more time. And as I'm turning the potentiometers on the simulator, the speed and RPM values inside the serial window should be updated as well. So I think that at this point we can move on to the next step, and that will be displaying those values in some graphical way on some display. And I will be using this display, which is the Nextion Intelligent Display, in the size of 5 inches with the resolution of 800 by 480 pixels. And the main reason for using this display is because it's very easy to use. Actually, in my recent video, I was using the very same display to recreate the Digifis dashboard from the old Volkswagen cars. You should definitely watch that video if you haven't seen it already. By the way, in that video, you will find out that you can easily switch to the 7-inch version of the Nextion Intelligent Display because it has the very same resolution. Anyway, back to our project. I've already prepared a design in the tool called Photopea. And Photopea is a free online design editor similar to Photoshop that looks like this, and this is the design. This is how it should look like when everything is finished and done, but of course those numbers will be dynamic as well as those gauges. So what I would like to export from Photopea is actually this image, so this background image with just the empty gauges and the numbers around those gauges. So I will go to File, Export as PNG file, and export those two empty gauges as a PNG file. But I will also export one more image, and that's this image, which will act as a guideline for positioning those elements, and maybe I will also show this layer so everything is kind of faded. And that should make it easier to position those labels inside the Nextion editor. So let's just export this image as the PNG file as well, and maybe name it position reference, and again export it as a PNG file. So we have the full screen background image and the position reference image. And then I will open the Nextion editor and create a new project, give it some meaningful name and save the HMI file. And as for the display, I have the intelligent display in the size of 5 inches. And if I click the OK button, it will tell me that I have to choose the direction of the device. So that will be this one, the horizontal orientation, and click the OK button. And the first thing that we want to do is to import our images. So jump to the Pictures tab and click this plus icon. And I will import both of those images into our project. And then I want to use this image as the background for the page. And to do that, I will change the STA attribute to be the image. Then click the Pick drop-down menu and select our image, which will be this one. Actually, for testing, it will be the R1, which is this one. Because again, I want to insert some labels and position them based on those big labels. And to add the label, we need to first have some font. And for that, I will go to Tools, Font Generator. And I was using the font called JetBrains Mono. And as for the size of the font, let's jump back into Photopea. And if I locate the layer, you can see that the size is 72 pixels. But I believe that this document and the Nextion editor are using different DPI settings. One is using 72 and the other one is using 96 DPI. So for our font size, we need to divide it by 72 and multiply it by 96, which will of course give us the size of 96 points. So inside the Nextion editor, I will set the size to be 96 points. And I will most likely go with all characters because we have enough space on the display. Just give it some meaningful name and then click the Generate Font button. And then save it somewhere, and it will ask you if you want to add this font to the project, which is something that we want. So click the Yes button and then close this dialog. And then inside the Fonts tab, we should have this font, and if I double click it, you will see the preview with all the characters. So let's add a new number component for the RPM value. So click the number component and move it around like so. And change the size a little. I will set the STA variable to be transparent because we want this to be transparent, and maybe change the value to be all 8s, so 8, 8, 8, 8, and that will make it much easier to align it with the background image using the arrow keys. And of course the color, the PCO attribute, should be white, so set the select button and change it to white color. And then I will copy and paste it one more time, move it to the right side for the speed value, and again use the arrow keys on the keyboard to change the position and align it based on the background image. I want also those small labels to be dynamic, so the RPM and the kilometers per hour, because maybe that might change to like miles per hour. And for that we need another font in a smaller size, so again go to Tools, Font Generator, and I will select the same font, the JetBrains Mono. And if I locate the layer inside Photopea, the size is 18 pixels, or 18 points actually. And again, we need to divide it by 72 and multiply it by 96. And that will give us a size of 24 points, which should be used inside the Nextion editor. So inside here, I will set the size to be 24 points. And again, use some meaningful name and click the Generate Font button. Then save it somewhere. It will show you the size. And yes, we want to add the font to our project. Close this dialog and add a new text component. And again, I will set the STA, the style, to be transparent. The font ID should be our smaller font, which is the ID of 1. Let me just show the preview of the font, which looks like this. So the font is number 1, and the text should be RPM. And of course, the color should be white. And then I will align it to match the position of the text on the background image and copy paste it one more time. But this time, change the text to be kilometers per hour. Like so, and again use the mouse or the arrow keys on the keyboard to set the correct position. And I think that at this point we don't need the helper background anymore, so select the page and set the pick to be the pick number 0 with the proper background. And we can move on and continue with the gauges, and although there is this gauge component, that's really just a needle component, not the filling of the gauge. So creating the round gauge in the Nextion editor is kind of tricky. You can of course use a lot of images of the gauge slowly filling up, and it's something that I've used in my previous videos. You can take a look, I will put the links down in the description. But today I want to try something different, and that is to have a custom font, where each character will be the gauge on some position. And I've actually already created the font. which is this one, and I'm using the Glypher Studio application, which is a free online application for creating fonts. And if I jump into the live preview and maybe make it much bigger, every character represents some state of the gauge. I think it goes all the way to the letter O, which is the fully filled gauge. And if I show the bounding box, you can see that I'm filling the entire space of the character of the glyph, and that's quite intentional. I will tell you why in a minute. I've actually ended up creating 3 different versions of the font, being the light font, the normal font, and the bold font. And what I need to do is to install those fonts, so click the install button. And yes, I probably have those installed already. And then I need to restart the Nextion editor to make sure that it recognizes the newly installed fonts. And again, go to Tools and Font Generator, and I will select my font, the normal version. And the reason why this gauge is as big as possible inside this glyph is because there is a limit of how big the font could be, and that's 254 points. If you try to make it bigger, it will not allow you to do that. Also, it looks like that the minimum size is 16 points for some unknown reason. So let's go with 254, then give it some meaningful name. And this time I don't want to go with all the characters, because even when in my font I don't have all the characters, for example, I don't have those characters, if I select the All Characters option inside the Nextion editor, it will still generate me those characters using some default font, which means that I want to specify which characters I want to generate, and I have the list of characters that are being used in my font, which is this string. So let me just put it in here so you can see the preview. So those are all the characters that I want to use because those are in my font. So back inside the Nextion editor, I will select specified characters and paste those characters, and then click the Generate Font button. Again, save it. It will show us the file size, and I want to add this font into our project, so click the Yes button and then close this dialog. And then I will add a new text object, set the style to be transparent, and the font should be our latest font, which is this ID number 2. Let me just open the preview of the font, so we can see all the characters as the gauge is progressing and filling up. So the font should be the font ID 2, and let's make it much bigger so we can actually see something. And as for the color, I will jump back into Photopea and sample this color, which is the RGB 174 and 255. So just keep this in mind, and in the Nextion editor, set those values. So use this violet color. And as for the text, let's go with any character, for example the letter O, which will be the fully filled gauge. Then maybe make it slightly smaller and position it using the arrow keys on the keyboard, like so. And then copy paste it one more time, and that will be for the speed gauge, and again position it properly based on the background image. Now before updating the gauge from the Arduino, I think that we can test how this gauge looks like and how they work using just the Nextion tools. And obviously if I click the debug button, it will show us the running model, but there is nothing happening because there is no code and no interaction. And since I want to test filling of those gauges, I will add a new slider component and make it much bigger, like so. And maybe change those colors slightly to be matching our theme, but that's of course just optional. And based on the position of the slider, I want to show a different character on this gauge, and I have 72 different characters available. So I will set the value of the gauge to be maximum of 72, going from 0 to 72. And then when I click the slider or move the slider, I want to set some character to the gauge. And let me go to help and open the instruction set. And I want to use the substring function for copying the character from the string. And there is some example down here. So the substring function is copying from the source text, which is the first one, to the destination text, which is the second one. Then there is the start position and the number of characters to be copied. So let me just copy this piece of code and paste it into the Nextion project. And I've already prepared all the characters that I have inside my font, which is this long string. So those are all the characters that I'm using inside my font. And I want to copy this into the gauge, which is a component t2, so t2.txt. So for the gauge, I want to copy this into t2.txt. The number of characters will be only 1, so just one character. And the starting position will be the value of the gauge, which is the h0. And the value is this attribute, the val value, so it will be h0.value. Let me click the debug button to try this inside the simulator. And as I click on the slider, I'm changing the image for the gauge, but as I'm dragging the slider, nothing is happening. And that's because inside our code, I only have code inside the touch press event, and I need to copy the very same code and also paste it into the touch move event. And if I press the debug button now, I should be able to move the slider and change the value on the gauge. So it looks like that it's working as expected. I can probably also update the value, which is this N0 component, and the gauge goes all the way to 6000 RPM, and we only have 72 steps for our slider, which means that we need to multiply the slider value by about 83. So again, for the slider code, let's just say that the N0.value equals the value of the slider, which is the H0.value multiplied by 83. And then I need to copy the same function into the touch move event as well, and then click the debug button. And now as I'm moving the slider, I'm updating the gauge as well as the value of the gauge. And let's try the very same thing for the speed gauge as well. So just copy and paste the slider and maybe this time move it up on the screen. And for this one, I want to update this gauge, which is the T3, so the T3.txt. And I should get the value from H1. And as for the speed number, the gauge goes all the way to 120, and again we have 72 steps, so I should multiply it by 1.66, but there is no support for floating point numbers, which means I will multiply it by 166 and then divide by 100. And again I want to use the H1 value, and I want to update this readout, which is the N1, so N1 value, and then again copy the entire code into the touch press event as well, and let's debug it one more time. And if I move the top slider, I should be updating the speed gauge and the speed value, and the bottom slider is updating the RPM gauge and the RPM value. So I think it's time to test it on the real Nextion display, and for that I need to first connect the Nextion display to my PC. And I can use the very same USB to TTL board as I was using previously for the Sparkfun board. But if I use a dedicated USB to TTL board right from Nextion, I don't need to worry about connection because there is this cable and one end of the cable connects to the USB to TTL board and the other end connects to the Nextion display. Which means that all that's left to do is to connect this board to my PC, and yep, it's using this strange USB cable that has the same connector on both sides. And so once the Nextion display is connected, we can go back into the Nextion editor. And in here I will click the upload button. And if you want, you can select the port, which will most likely be the last one, and then click the Go button to upload the sketch to the display. And it only takes a few seconds. And once this is uploaded, the display should look like this. And sure enough, I should be able to move those sliders and change those gauges. Which means that everything works as expected, and before connecting everything together, I will do just one small change for the Nextion display. And that is to hide those sliders, and I will do it in a way that I will just lower the alpha to be 0, so they are still visible, they are just not being drawn. And I will do the same thing for this slider. So if I click the debug button, I know that those sliders are still there, so I can just move those around, but they are not visible for our final project. So click the upload button again, select the correct port and click the Go button. And this time this will be very fast because it's not uploading those images again. And so if we want to test those gauges, we can still move those invisible sliders. But of course what we want to do is to connect the Arduino to the display and send the correct values to the display. So maybe let's talk about what kind of data we want to send to the display. And we've actually already talked about this, at least partially, because if I select the slider, we have this comment saying N0.value equals something, and that's pretty much what we want to do from the Arduino. So if I open the debug simulation, there is this area where I can input some instructions, so I can say N0.value, and N0 will be for the RPM readout. If I just move it to the side, so N0 is the RPM readout, and if I set it for example to 6000 and press the enter key, it will change this readout to 6000. And in the very same way, I can change the gauge, which is the T2, and that's the text object. So instead of value, it will be TXT. And I need to send the text, of course, inside quotes. And then I can set it to some character, for example, A, or maybe O is the full gauge, and so on and so on. So this is what we will be sending from the Arduino to the Nextion display. We will be sending this using the serial communication, and one important thing which might not be obvious is if I switch to hex code, the last three characters should be FFFFFF, which if I use this string area, it will just add it automatically. But if we send it from the Arduino, we need to make sure that the last three characters are the decimal value of 255 or the hex value of FF. And that's pretty much all that we need to know. Let me actually move this to the side so we can test all of those individual elements. So again, the T2.txt, that's the gauge for the RPM, the N0.value, that's the value for the RPM, the t3.txt, that's the speed gauge, and finally the n1.value, that's the speed value, so for example 120 kilometers per hour. So let's just keep those names in mind and let's jump back into the Arduino IDE. Actually, this string is something that we will need as well, so just copy this into the clipboard and again jump back into the Arduino IDE. Now just to refresh our memory, we are using the Arduino Leonardo board, which has two serial ports. The first one without any number, that's the one that's being emulated by the USB, and we are using it to send messages back into the PC. Then we have serial 1, which is on pins 0 and 1, and that one is being used to communicate with the Sparkfun OBDII board. Now why am I saying this? It's because we need one more serial port to communicate with the Nextion display, because the Nextion display also uses the serial communication. And the problem is we are out of hardware serial ports with the Arduino Leonardo board, so we need to emulate this in the software using the software serial library, and that one should be installed by default. If I go to File Examples, there should be a software serial folder, and there is some example, so let's just open the software serial example, and hopefully it will be easy to understand, and there are some notes that for the Arduino Leonardo, we should use some of those pins. So let's for example go with pins 10 and 11. And let me actually put those two sketches side by side. So we want to include the library inside our code. So I just put this include of the software serial library. And then we want to initialize it. And let's actually give it some meaningful name. For example, let's call this Nextion software serial and use pins 10 and 11. And then as with all the other serial ports, we need to call the begin function. So I just call the begin function, but our software is named Nextion software serial. And by default, the Nextion display is using 9600 baud for the communication speed. And then we can use the print line, the print function, and the write functions. So I don't need this sketch anymore. And let's just copy the name of the serial port and go into our main loop. And so once we get the RPM value, we want to send the RPM value to the Nextion display. And for that, we will just use the print function, and the label that holds the value is n1, so n1.value equals, and in the next line, I will set the RPM value, and then we need to send 3 characters of having the value of 255, and we can use the write function to write just 1 byte of the value 255, and we'll just copy and paste it 3 times. Actually, I think I've made a mistake. I think that the value for the RPM is n0, and then I will just copy everything and paste it after we are getting the speed value, and of course send the speed value to the Nextion display, and this time the readout is called n1, and we want to send the speed value. Now before we update also the gauge, let's just try that on the Arduino Leonardo with the Nextion display being connected to see if everything works. For that, I will first upload the sketch to the Arduino Leonardo, so hit the upload button. Then it will restart the board, and after a while we will be getting the RPM and the speed values, because the Arduino Leonardo is still being connected to the Sparkfun OBDII board, and the Sparkfun OBDII board is being connected to the OBDII simulator. Which means that the only thing that is not yet being connected is the Nextion display, and I will connect the ground to the black wire on the ground on the Arduino board, and then the 5 volt, which is the red line, to the 5 volt on the Arduino. Then we have the yellow wire, which is the RX, and that should go to pin number 11 on the Arduino, and the blue one, which is TX, that should go to the pin 10 on the Arduino. And as soon as I connect everything together, I can now see the RPM and the speed value on the Nextion display. Obviously the gauge is not updating yet, but that's something that we will do right now. So let me just play with those potentiometers for a second, and then jump back into the Arduino IDE. In here, I will create a new variable that will hold all the individual characters for the gauge. And again, that will be the array of characters, and let's call it gauge string. And I should have all the characters still in the clipboard. One thing to note that we are using the backslash character, and I need to type it as the escape sequence, otherwise it will not work. And then after we send the RPM value to the display, let's just also update the gauge. And maybe to make it more understandable, I will create a new integer variable and call it gauge string index. And that's the position of the character that we want to send to the gauge. And obviously it will be based on the RPM value, but we need to remap the value because the RPM value goes between 0 and 6000. And we need to remap it to go between 0 and 72. But if the RPM value is bigger than 6000, it will be actually bigger than 72, and that's not what we want. So I will also use the constraint function to constrain this value to be only between 0 and 72. After that, I will just send this value to the display, and the component name is T2, and it's not a value, it's a text component, which means that I also need to send the quote character, and actually need to send it one more time after the value, so just send the quote character only. And in between, I will just send one character from the gauge string variable, and the character index will be the gauge string index. So let me just copy the very same code for also setting the speed gauge, paste it down here, and we don't need to define this variable again. And this time we want to, of course, use the speed value, and that should go between 0 and 120. And again, we will remap it to go between 0 and 72, but not go outside of this range. The component that we are changing has the name T3. And I think that the rest of the code could stay the same, because we are again sending one character from this gauge string to the Nextion display. So let's just upload this one more time to the Arduino Leonardo board. And there is some problem because somehow I haven't defined this variable to be the array, so let's just fix this and try to upload it one more time. And not only we are updating the value inside the gauge, but also the gauge itself for both the speed and the RPM values. That's how you create the fully functional dashboard using the Arduino Leonardo, getting the data from the OBDII port from your car using the OBDII to UART adapter board, and then updating the graphics on the Nextion display. Now I know that this video is quite long, but I still want to talk about a few more things. First of all, I did told you that I have 3 different versions of the gauge font, but I haven't showed you how this looks like. So if I select this T3 component, this is the normal version of the font, this is the bold font, and this is the light font. And although it's not working well with this particular design, you can use it for different designs. And of course, the biggest advantage of using the font for the gauge is that you can use this font generator tool and generate the font in any size. Unfortunately, this is the biggest size that you can use, and that is the reason why this design looks the way it looks like. You know, having those numbers outside of those gauges, because I cannot make the gauge any bigger. Another advantage of using the font is that you can easily change the color by changing this PCO attribute. So you can, for example, say that if the value exceeds some threshold, you can change the color to, for example, red instead of violet. But I will probably keep it for the next video. Now to put this inside the real car, I've 3D printed this very simple holder. The Nextion display just snaps to the front of the holder, and then I was using screws to just attach the Arduino Leonardo board and the Sparkfun OBDII board. And while this is of course just for testing purposes, it's much easier to just handle this one unit instead of having 3 different boards. I've designed this part in the Fusion 360, and let me go all the way to the beginning, but I have used a very simple tools, mainly the extrude tool to extrude bits and pieces, and those big holes. Those are for the components on the Nextion PCB which are sticking out too much, like for example this battery holder or this connector. And then if I flip it around, I have added those small extrusions that will fit inside the holes of the Nextion PCB. Then I have added some holes for the Nextion board and the Sparkfun board. And even more holes because the Arduino Leonardo has those pins as a through-hole components, so it's sticking out a little bit on the bottom of the PCB. And then to hold the display in place, I've added those little tabs, so I just extruded those pieces and added a little bit of extrusion. And then I've copied this around the whole board, so having it 4 times. And of course I could have used screws, but I wanted to try those tabs to see if they work even without any supports. And I was actually able to print those without any supports, and they work just fine. Then I've worked on the actual holder, and there is a reason why it looks this way, and that's because I already have some holder inside my car from testing a very different product, so I thought maybe I can use it for this display as well. And while this works without any problem, when I have the display placed in the car with the holder in the middle, it's very hard to see the RPM gauge and the speed gauge at the same time. So I've decided to actually put it on the left side and on the right side as well, so I can move this display around and capture the video for today's tutorial. Then I have of course exported this body as a mesh in the 3MF file format. And then I have opened it in the Bamboo Lab Studio, because for 3D printing I will be using the Bamboo Lab X1 3D printer. As you can see, it's upside down, so I will click this Auto Orient button, and then I will pretty much keep the default settings, so just click the Slice Plate button. That will slice the model, and the only thing that, it's not perfect is this piece. So inside the holder I had a quite long bridge, which is this part, but it actually printed out without any big problem. I mean, I was worried about those steps for the display, but there was actually no problem at all with those steps. So the only thing left to do is to click the print plate button and click the send button to send it to the 3D printer. And I did start with the PLA, then moved to the ABS, and finally I have used this PAHTCF, which I believe is the most advanced material that the Bambu Lab is currently selling. So here is a short time lapse of 3D printing this piece. And here is one more, just because you can see it better with the lighter material. Here is the final 3D printed piece, and again I'm using those small screws, those are plastic screws, to attach the Arduino Leonardo board and the Sparkfun board, and the Nextion display it just snaps to place using those tabs. As usual, all the source files are on GitHub, the link is in the description. And before I end this video, let me tell you one more thing, and that's this Nextion display is great for testing because it's very easy to use, but I wouldn't suggest to use it in the car because it has quite low brightness. I would go with something like the OBDII display, and thankfully I do have a video how to use OBDII displays. I will put the link down in the description. And here I was recreating the gauges from the Ford Focus RS using again the Arduino Uno board and the OBDII display. The display is great, it's bright, it's fast and cheap, but unfortunately not very easy to use, but hopefully this video will help you with that. I actually plan to use more OBDII displays in my future videos. And that's pretty much it for today. If you have any questions, please put those down in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.